Hey everybody, welcome to another episode of Headlines. Today we're going to talk about Neanderthal teeth and the techniques they use to date these teeth and why, especially on the Italian peninsula, this will help piece together the hominid family tree and really find the between the modern humans and Neanderthals, find that link between them, the last common ancestor between them. And you see a lot of this in crime drama shows and forensics. If you find somebody's teeth, you can kind of ID them and get all this information. And anthropologists are going to use this kind of technology as well. And it all started with this fossil tooth study that they published in the journal PLOS1. And they found 450,000-year-old teeth on the Italian peninsula, and they're using basically this forensic analysis to date back to the Middle Pleistocene, basically. So there are some telltale features of the Neanderthal lineage in ancient humans, like they know that we share DNA and all that kind of stuff. But this tooth is actually going to fill in some gaps in our family tree, the hominid family tree. So there's an unknown common ancestor between the Neanderthals and Homo sapiens. But they don't really know when they diverged. Some say Homo sapiens evolved 300,000 years ago, but the last video, a couple videos back I did, they found a Homo sapien, an anatomically modern human basically, that was 315,000 years old. So they probably didn't evolve then either. They probably evolved before then. So Homo sapiens probably goes back, it's probably safe to say it goes back further than 300,000 years. And the Neanderthals, some genetic studies suggest that the Neanderthal lineage split as long as 650,000 years ago, even though the oldest fossil evidence for Neanderthals is only about 400,000 years. But then again, you know, that with the fossil remains, you can only extrapolate so far. So if you find a 400,000 years old, well, it was fossilized 400,000 years ago. So who knows how long it was there before then. They're kind of ballparking it like about 500,000, a little bit beyond 500,000 years. So that means the last common ancestor should go back around that time as well, between 500,000 to 1,000,000 years ago. Assuming these are all assumptions, and frankly this is all speculation. But this forensic analysis thing is probably going to help pinpoint and give us a better ballpark range. Because there is no doubt that there is some sort of common ancestor with Neanderthals and us. They just don't know what it was and when it lived. These group of French scientists, they use detailed morphological analyses and micro CT scanning techniques to measure 450,000-year-old teeth. I mean, it seems like you just put this into a machine and then the results come out the other end. But no, you have to get all the different angles. It's very painstaking work, and it's not easy, and it's very expensive. So the teeth were then compared inside and out to those of other ancient human species, and it revealed that they have Neanderthal-like features. So it's pretty safe to say that it does belong to a Neanderthal, although, you know, there is a margin of error here. It might not. But so far, everything seems consistent that it is a Neanderthal tooth. So Zanoli, she says, with this work and other recent studies, it seems now evident that the Neanderthal lineage dates back to at least 450,000 years ago and maybe more. This is just based on this tooth. This age is much older than the typical Neanderthals, and before our study, it was unclear to which human fossil species these Italian remains were related. Here's some pictures of the teeth, and apparently it's more broad, and they're bigger. I mean, this looks pretty intact, this virtual rendering of the Visagliano and Fontana Ranuccio teeth. Aside from this, most Neanderthal fossils are more recent, dating from about 130 to 40,000 years ago. So the evidence of the species' earlier period obviously more rare. So these teeth from the Middle Pleistocene were found at two different sites, one near Rome and one outside Trieste. Visagliano. And together, these tiny fossils represent an intriguing piece of physical evidence that supports the findings of genetic studies of ancient human ancestry, of course. Just like what I said earlier, this study demonstrates many of the features of Neanderthal teeth that are present in Europe as far back as 450,000 years ago, which is farther back in time than any other Neanderthals identified in the record. So this pushes back the hard evidence of the split of Neanderthals from modern humans, and it is entirely consistent with the divergent dates coming from ancient DNA analyses, which suggests that the divergence occurred before 450,000 years ago. So they have DNA analysis, and those results suggest, based on the DNA sequencing and stuff, that the common ancestor goes way before 500,000 years ago. But they just didn't have hard evidence of it. But now that these teeth have been analyzed, the results of the analysis of these teeth are consistent with the DNA analysis. So there's a big lead here, essentially. So the other thing that this reveals is how complex the genus Homo, the tree is. And there might be a more roundabout way that correlates the Neanderthals and Homo Sapiens rather than just one direct ancestor. That it might be a winding, curvy path. It may not be a direct A to B relationship, largely because there are other European fossils of comparable age that lack Neanderthal features of these specific Italian fossils. And so that therefore indicates that other kinds of humans besides Neanderthals were existing in Europe during this time. So again, actually when I do a lot of these Neanderthal episodes, I always talk about how the possibility that back in, especially in the Middle Pleistocene and earlier, there are probably all different kinds of Homo species walking around, just like there are different types of bears and other animals and horses, stuff like that. So we probably weren't the only groups back then, for sure. There might have been a bunch of different races. One prominent example is Homo heidelbergensis, which was present in Europe at that time, and also Homo erectus, which is a lot older, and their relationships are all unclear. So the shapes and structures of the teeth provide a valuable diagnostic tool to discriminate between our various ancient hominin relatives and the people today. The one question that a lot of people have is, how does one tell a Neanderthal's tooth from modern humans? Well, the most glaring obvious thing is the size. So the teeth and jaws get smaller as we get closer to the present day because of dietary changes and agriculture and cooking. So we don't need the brute strength to crack through things like we do now, because we can just cook everything and everything's soft. The tooth interiors are different, enamel thickness, pulp chamber size, and destructive analysis. Oh, let's go over destructive analysis real quick. So in order to do some DNA analyses, you need to kind of destroy what you're studying. But with the CT scanning and reconstructing a virtual image of what the teeth are, the scientists can analyze them to a high degree without having to cross-section them and destroy what we're trying to look at. So that's one big advantage of the CT scanning. And then from there, we can learn about the lives and diets of ancient humans that the teeth belong to, obviously. The scope of information that teeth can reveal are not to be underestimated. And the problem with finding teeth are even though they are typically the last part of the human body to degrade and deteriorate, they have a long lasting, they last for a long time. They're hard to find. They're little teeth, So these are like literally small nuggets of information that are just lying all across the landscape. And you can glean so much information from them. It's like a window into their personal life. You can tell their age, what they're eating, their hygiene, even their migrational patterns. And all this information is invaluable toward understanding and reconstructing human history. So let me know what you guys think in the comments. And I thought this was a really good article that really highlights the difficulty and the complexity of what we're dealing with when we're dealing with Neanderthals and trying to figure out who our relatives were and what they were doing, and really try to fill in the colors of the snapshot that we have of 500,000 to 1 million years ago. So let me know in the comments, and I'll talk to you guys later.